Hey guys, Mr. B here. In this video, we're going to be going over the chapter 18.3 notes on long-term changes in climate. So this section of notes is primarily going to be talking about how climate has changed over a long period of time naturally on its own. Okay, so this is not about like current day climate change or human, climate change. This is about just natural causes in Earth's climate over a long period of time and why they can occur. Okay. So we need to again remember what climate means. So usually on a day-to-day basis, we have weather, which means that it can be rainy one day and sunny the next day, or rainy during one part of the day and then sunny later on in the day. And it changes pretty quickly, right? Climates take a very long time to change. They're usually an average about weather patterns and precipitation and temperature over a long period of time, both in small areas and around the whole world. Okay, so because climate usually is very slow to change, the consequences of that change are usually very big because they have a very large impact on a lot of things. So when we are looking at ancient climates, there's a principle that scientists oftentimes have to keep in mind, and that is that when they're studying ancient climates, we basically have to make the assumption that if plants and animals today need certain conditions to live, then it's very likely that plants and animals in the past also needed those same conditions. Okay, so scientists use this because when they're looking at ancient climates and they see, indications that could tell us whether or not there was like a lot of rainfall or it was dry or temperatures were high or low, we could then assume that if temperatures, let's say for example, are really, really high during a certain period of time, looking at an ancient climate, we could assume that maybe vegetation was, doing very well if it was wet enough, or if it was high temperatures and very dry. We could assume maybe vegetation or plant growth was not very good during that time because currently today, if it was very hot and dry, plants wouldn't grow very well, so we'd make the same assumption in the past. Okay. So when we're looking at ancient climates, there's a couple of different things that we use to actually determine what an ancient climate used to be like. One of those things that we use is pollen, right? So each type of plant has a particular type of pollen that it gives off. And a lot of times this pollen will just float through the air, and of course it lands in lakes and rivers and things like that, and it'll just get trapped there and it'll sink to the bottom. So if you look at the bottom of a lake bed or you collect material, right, which you might consider to be mud, it's actually lots of material of different things, but pollen is a big proportion of that. So scientists will collect giant cores of mud and stuff from lakes, also from the ocean, and look at the pollen and materials that are present in different layers of that lake bed, and that will give us an idea of what kinds of plants were around, alive during that time. And it can also tell us about what the climate used to be like. So if you find lots and lots of pollen in a certain layer of the lake bed, it probably gives you a good indication of that temperatures were, in a good place for plants to grow. There was definitely enough water around for plants to grow well and things like that. Versus if there's other layers where there's very little or no pollen, it could tell us that during that time there was not a whole lot of plant growth. Maybe temperatures were cold and things were frozen, or maybe there was a long period of no rainfall or very little water. So again, very, very poor plant growth, stuff like that. So pollen is one first indicator of what ancient climates used to be like by looking at how many plants and things were around during that time. Another is tree rings. So tree rings can be used to learn about ancient climates. Now, obviously, we don't typically use tree rings from trees that we can find just around everyday basis here, because most trees don't live for that long. There are certainly some trees on planet Earth that live for a very long time, like the redwoods in San Francisco. They're estimated to be a few, I think, million years old, but you can't really cut into them because they're protected. So a lot of times we'll find tree rings from petrified trees, tree fossils, basically. And we can look at the amount of rings that are on that tree and kind of the thickness of each one. So, as most of you know, when a tree grows, it adds a ring onto its trunk, which is how you can determine how many years it's been alive for. But you can also look at how thick each ring is. The thicker the ring, the better and the longer the growing season was during that time. And the thinner the ring is, the worse the growing season was. So in really good growing conditions, you could have a lot of tree rings on a petrified tree trunk or fossil that has really thick rings, and you could say, oh, temperatures and water and stuff were probably really good during that time. Maybe CO2 levels were high, and things were thriving, versus other times if you find thin tree rings on that same tree, that might tell you that during this time temperatures dropped and there wasn't good growing, there wasn't maybe enough rainfall and stuff like that, right? So again, here's just an image to kind of give you an example. If we look at these kind of rainy season, dry season here, and they kind of zoom in a bit more, we can see that the rainy season ring is very thick and the dry season ring is much, much thinner. So again, this gives us an idea of how much rainfall was there during this time when this tree was growing, what were temperatures like, maybe it was good growing or not good growing, stuff like that. So, all right. So again, we're not going to be going over the questions here in this video. If you want to see me go over those, you can go watch that one. So let's keep on talking about information here. All right. So other than, of course, looking at ancient climates, or by looking at ancient climates, what else have we learned about Earth's history? One of that is that Earth has gone through many climate changes over its lifetime. Okay, over millions of years, we've seen that Earth has these tendencies to go through warm periods and cold periods. Okay, the cold periods, of course, we would call an ice age, as most of you may be familiar with that term, or glacial episodes. And the warm periods would just be, regular times. And so over time, Earth has gone through this kind of fluctuation of warm temperatures, cold temperatures, warm temperatures, cold temperatures. And there are some reasons why we think some of these things have occurred, but all we know is that it happens to be very cyclical, that Earth does this for some reason or another. Okay, so during these cold periods, these ice ages, huge sheets of ice cover a large portion of Earth's surface. We call these things glaciers, right? And you might be thinking like, oh, it's just kind of like cold and stuff, and like it's winter all the time. Not quite, right? So imagine that we had a layer of ice that covered all of Canada and even down, of course, into our home state here, Minnesota, and it was miles thick, right? This isn't an ice age where it's like, oh yeah, there's snow outside. This is like a layer of ice that is miles thick, just sitting on top of the ground here because of how things freeze. This is what we call an ice age. And we think here in Minnesota, the reason why we have so many lakes here is because during the last ice age, these large sheets of ice which push down on the ground, of course, they're very heavy, right? So they cause the ground to kind of buckle downwards as all this weight is on top. And so as the ice retreated at the end of the last ice age, there were all of these potholes and low spots where the ice pushed down on the ground, and as the ice melts and turns into fresh water, it fills in those holes and essentially creates lakes, right? So this is the reason why we think Minnesota is so rich in lakes, is because during the last ice age, most of our state was covered in ice, which then when it retreated, it left all this fresh water and all these holes that got filled in, and there's all of our lakes, right? So of course there's the Great Lakes, as we know, also in our general area. And so a lot of states with a lot of lakes and stuff are usually up in the north, whereas the southern states, Texas, Oklahoma, are relatively dry. They don't have lakes very much, and mainly because during an ice age, typically glaciers wouldn't go down that far. So we can see there's a kind of a graph here that shows over the last few 100,000 years. There's temperatures of warm temperature and cold temperature, warm temperature, cold temperature, and so this again is kind of fluctuation that's normal. And right now currently we're in a warm period, which is one reason that many people believe that climate change isn't occurring, is because naturally Earth goes through these cycles of warm and cold and warm and cold. And so some people think we're just in a warm period right now, right? That's why temperatures are rising, but give it a few thousand years or whatever, 100 years, and temperatures will start to drop down as we start going towards the next ice age. Who knows, right? So there are, of course, pieces of evidence to suggest that is not the case. But either way, so as for what causes these climate change occurrences, right? Like, why do these things happen? There's a couple of different reasons why we think that Earth goes through these cycles. One is variations in the position of Earth relative to the sun. The sun, of course, goes around the Earth, or the Earth goes around the sun. And there are certainly times when the Earth is closer to the sun and further away from the sun, and it kind of fluctuates a little bit. So there can be times when the Earth is a little bit closer, in which case maybe it's getting some more solar energy versus a little bit further away and it's getting a bit less. And this can cause, of course, ice ages to trigger or temperatures to drop, which could trigger an ice age. Changes in the sun's energy output. The sun itself is not constant. There are times when it's more active. There's times when it's less active. That could also change the temperatures here if the sun is more active or less active during certain periods of time. Volcanic eruptions, we think, have a big effect because they release a lot of carbon dioxide, which is a greenhouse gas, and that can, of course, raise temperatures or lower them, depending if there's not very much of it, as well as the movement of the continents themselves. So we're just going to recap those here real quick again. So again, Earth revolves around the sun. Typically, the time of the year when it's closest to the sun is actually in January, and it's further away in July, which many people find strange because January typically is cold and July is warm, right? So you'd figure in January we'd be further away, and in July we'd be closer. Well, remember, the seasons are caused by the tilt of the Earth, not where it is around the sun. So, but the Earth does fluctuate in terms of how far away it is from the sun over a period of about 23,000 years, as well as, of course, our angle itself of the Earth kind of wobbles. So the angle of the Earth isn't always the same angle all the time. It can shift a little bit, which can cause an ice age to trigger. Okay, so there's a little diagram here that kind of shows this, but so that's one. Two, again, solar energy. The sun itself is not constant in terms of how much energy it outputs all the time. There are sunspots on the sun, which typically trigger more activity on the sun, and so throughout usually what we see about 11-year cycles, the sun is more active and less active. So there's times when the sun can certainly be giving off more solar energy, which can cause temperatures here on Earth to rise, or it can be giving off less solar energy, which could cause temperatures here on Earth to drop. So this also could happen, but this is, again, usually going to be over a long period of time. It's not just like, instantaneous or over a few years. As for volcanic activity, major volcanic eruptions usually release very large amounts of gas and ash into the atmosphere. The gases, of course, can stay in the atmosphere for a very long time and heat up the ground, especially if it's, greenhouse gases like carbon dioxide and stuff like that. But also, a lot of these gases and ash especially will linger in the air, and it actually blocks a lot of the sunlight that comes in from space, which can then cause the ground to cool down because sunlight is not getting through anymore. And that can cause temperatures to drop and trigger an ice age. So, here's an image here of an eruption in 2011 in Japan. And this giant plume of ash is going to cover a very large area for probably months. And that can cause temperatures to significantly drop because the amount of sunlight the ground's going to get is much less. Temperatures will drop. And again, if this were to occur over a very large scale, this could cause an ice age to trigger. And once an ice age starts, it kind of just takes over. Okay, so that also is the reason why maybe ice ages could have happened in the past. And lastly, of course, the movement of the continents themselves. As the continents move over time, that changes not only the location of the land, but it changes the location of the ocean, and primarily ocean currents. Okay, so we know that ocean currents play a very large role in climate and how energy and heat is distributed around the globe because the ocean is constantly moving. If the continents shift, those patterns, those ocean currents will change in terms of how they move, which can then cause certain locations to cool down or warm up, depending if ocean currents move away from there and whatnot. And that can trigger an ice age in that location, which can then again become global. So there are a lot of factors over long periods of time that can cause the climate on Earth to change. And we're not really sure, again, if maybe current today climate change is happening because of these things, but it's very unlikely that many of these causes are what's happening today. Okay, these are usually over long periods of time. There are lots of other pieces of evidence that suggest that current day climate change is human caused, not so much natural caused. But there certainly could be natural causes that are attributing to current day climate change and not only human-like stuff. So, all right, anyway, that is the end of this section of notes. Again, if you want to see me go over the questions, there's a video on that one, so you can go watch that one next. And that's it. So I will see you in the next video. All right.